Welcome! In this video, we're going to continue working on our Connect4 library that we're building in TypeScript. Previously, in the first video, we took a look at the rules and the gameplay of the game Connect4, and we started to build out the initial Connect4 class by adding our private properties, getters, and some of the public methods for our API contract for our library. In this video, we're going to take a look at adding some of the game initialization logic, the ability to reset a game, and then we're going to look at how we're going to start testing our code using the UVU framework. If you missed the first part of the series, there'll be a link down in the description, as well as a link on the screen now. There will also be a link in the description to the completed source code for this video and the previous one. So currently, when we create a new instance of our Connect4 class, we are currently not doing anything in our constructor. And typically, your constructor is where you would have your initialization logic for setting up anything that's needed for your class. So for our library, what we're going to do is we're going to update our constructor to initialize our game board with our empty values. So for our 2D array, we're going to pre-fill it with zeros to show that there's no game pieces there. We're going to set who the current player's turn is, so it'll be player 1, and we're going to reset any information tied to if the game is over or who won the game. So currently in our class, we have all of these defined as properties, and we're setting initial values up here, except for game winner, it'll be set to undefined. So we're going to take this logic and place it inside our constructor to have our initial values. So what we'll do is we'll go in our constructor. We're going to do this dot is game over. We'll set that to false. We'll do this dot game winner, and we're going to set that to undefined. And we'll do this dot player's turn, and we're going to set it equal to player.1. So then for our board, what we're going to want to do is iterate over our 2D array, and we're going to want to create so then for our board, we're going to go ahead and create our 2D array. Instead of doing this inside our constructor, we're going to create a new method to have this logic. So we're just going to call this new method. So we'll do initialize grid. And then what we'll do is we'll go ahead and create that private method down below. Great, and then so inside this method, the first thing we're going to do is reset our board back to an empty state. So we'll do this board will equal an empty array. Then we're going to want to go ahead and create our 2D array. So to do that, we're going to need to know the number of columns and the number of rows that are inside that make up our board. So what we'll do is at the top of our file, we're going to create two new variables. We're going to do const number of rows. I'm going to do const number of columns. So typically we'd have this logic outside in a configuration, or we'd allow the consumer of our API, of our library, to pass in these values. For now, we're just going to keep them inside our file here so we can reference them and use them as we're building out our library. So then what we're going to want to do is we're going to create 6 arrays, which will represent our rows, and for each of these rows, we're going to want to populate them with 7 values, which will be our columns, and we'll want to push in the value 0. And so one easy way to do this is we can use some for loops. So what we're going to do is we're going to do a for. So what we're going to do is we're going to do for. We'll do let I equal 0. If I is less than our number of rows, then we'll increment I. And then what we'll do is we're just going to copy this line here. And we're going to create a new variable. We'll call it j. And if j is less than our number of columns, we'll increment j. So what we're doing here is we're just creating 2 for loops. One is an inner for loop, and that's this one here. And basically, we're creating a new variable set to 0, and as long as that value is less than our variable here, so our number of rows 6, we're going to keep iterating through this loop. And once one iteration of our loop completes, we go ahead and add 1 to it. So in theory, we should iterate 6 times from 0 to 5, since that'll be less than 6. So in each of our iterations, we'll want to create a new array. So we're just going to call this row. So we'll do const row. And our type will be a cell range array. And we'll set it to an empty array. Then in our inner loop, what we'll want to do is push in our zeros into this row. So we'll do row.push, and we'll go do 0. And then what we'll want to do outside the loop is we're going to want to add that row to our board. So we'll do this board.push, we'll do row. All right, with that should now initialize our board to be a 6x7 grid with values for each representing each cell. All right, so now that we finish our game initialization logic, we're going to take a look at adding in game logic for our reset game method. So previously, when we planned our functionality for our class, we wanted to give the clients that are using our library the ability to reset the game at any point. When this happens, we want the user to be able to start a new Connect 4 game without having to create a new instance of our class. And so to do this, we will need to basically reset the game state back to what we're doing in our constructor. So we're going to be basically doing the exact same logic in our reset game method. And so since we're doing the same thing, this is a good opportunity to refactor our code and take this logic and place it into a new method that we can use both in the constructor and in our reset game method. So to do that, we're going to create a brand new private method. We're just going to call this initialize game. This method won't return anything, so we'll set the return type to void. Then what we'll do is we're just going to copy this code here and remove that, and we'll call our new method. And then down in our method, we'll go ahead and paste in that code. All right, so then we should be able to just go ahead and call our new method inside our reset game. We'll copy this from our constructor, come down to reset game. There we go. All right, so before we start adding any more logic to allow a player to add a game piece to our game, what we're going to do is we're going to talk about how we can actually test the code that we've written so far. So as part of our initial project skeleton, we set up the project initially to support tests that were written with the UVU framework. And there is a folder called tests that has a few files with some sample code that shows how these tests work. So if we go into our source code, if we go into test, and we open up our Connect4 TS file, this is one example test that's previously written. So in order to test the code we are creating, we're going to be adding new tests to this file here, which will help us test the functionality. So as an example, before we continue, we're going to go ahead and add in logic to test our initialize grid as well as our reset game methods to make sure they're working accordingly. So one thing to note is we will not be doing a deep dive into the UVU test framework, but we will discuss some of the key concepts of how that framework works shortly. So in order to go ahead and run your test, you want to go ahead and use the test script from the package.json file. So to do that, you can either do npm run test, or if you're using yarn, you can do yarn test. What this will do is it's going to use the UVU CLI to go ahead and execute our test and make sure everything's passing. So right now our test isn't doing anything. It's just creating an instance of our class and making sure that instance is an instance of the Connect4 class. And so you see our tests are passing. So when we run that command, the UVL CLI will go ahead and output a summary of the tests that were ran. It will go ahead and output which files were tested. It will output some information regarding the test, as well as how many tests ran and how many were successful. Then it will go ahead and summarize how many tests were ran altogether, how many passed, or skipped, and the total duration. So now that we know how to actually run the test, let's go ahead and review the code in our Connect4 test file. So in the code, the first thing we do is we create a function called setup initialization test. This function is just a helper function to group our code that are related to a specific piece of functionality that we want to test. This will make it easier for us to run one particular set of tests, and it will help our code be more readable. So in the setup initialization test function, we first create a suite. So a suite is just a way for us to group tests together with the UVU framework. To create a suite, we call the UVU suite method, and we provide a name for our suite, so connect for initialization. So if we take a look at our summary, you'll see that this name that we provide to our suite matches the summary name that's outputted here. After we create our suite, we then call the before.each methods on this of our suite instance. This will allow us to register a callback function that will be invoked before each of our tests that run in our suite. The callback is useful for setting up any variables that we'll need for our test, as well as grouping code together that is common across all tests. As an example, in our test here, we're creating a new instance of Connect4 class. So instead of having to do that inside each of our tests, we can just do this one time in our before each, and all of our tests will have this variable initialized to a new instance. After the before each, this is where we actually add the test for our suite. So to add test, what you do is you reference your suite, you pass in then the name of the test that you want to run, and then you pass in a callback function that will be invoked to run the logic for the actual test itself. So in our example test right here, all we're doing is we're just asserting that our Connect4 variable is an instance of our Connect4 class. Then the last thing is for your test to actually run, you need to call the run method on your test suite, which we do here. If this is not included, UVU will not actually run those tests. So as an example, we comment this out and we rerun our test command. You'll see now we only run the test in our index.ts file. Our Connect4 TS file runs, but there's no tests that are actually running. So there's nothing added to our summary. So currently our tests are set up to pass. So to show you what it looks like when there is a failure, what we're going to do is we're going to modify our test here to fail. So instead of being an instance of the Connect4, we're going to say that our variable is an instance of a string. So now if we go ahead and rerun our test, what will happen is we'll see that our test now has an error. So we'll see that only one of our two tests passed. And if we scroll up, we can see that our Connect4 initialization, the name of the specific test that failed, so it should be instance Connect4 class, this one here, it will now say that instance of is not an object. So typically when your tests fail, there will be some type of error related to that test, and that'll allow you to debug further. So there was a lot of information presented here. However, in summary, the main things that you'll want to take away are suites. So suites are a way for us to group our test, this here. Tests are the individual function that will test some type of functionality in our code will be added to our suites. Finally, for your test suites to run, you just need to make sure you call the run method, and that will make sure that your suite will actually run when we use the UVU CLI. So now we're actually going to add in logic to test the functionality that we added for our reset game state and our game initialization. So for these tests, what we're going to do is we want to test that our game state has an empty board. So we have our grid and it should be filled with zeros. We should validate that there is no current winner assigned to our game instance. The game should not be in the game over state, and it should be the first player's turn. So to do that, what we're going to do is I'm just going to copy this block of code here, and we're going to modify this to be one of our new tests. So what we're going to do is we're going to reference our suite. We're going to provide a new name for our test. So I'm going to do, we're going to check that the game is not in the game over state. So we're going to give our tests a title. So I'm going to do should initialize the game, and the game should not be over. And then inside here, this is where we add in our logic. So the first thing I'm going to do is I'm going to grab a reference to our isGameOver property on our class. So we're going to do const is game over. I'm going to set this equal to connect4 dot is game over. Then what we're going to want to do is we're going to validate the type on our variable. So we're going to validate that this is a Boolean, and we're going to validate then that the value is actually set to false. So to do this, we're going to use assert. So on the UVU framework, there is the assert library that will allow you to assert various things like the type of variables, the values of them, as well as like, is it an instance of a particular thing, like a string, an object, or a particular class. And so what we're going to do is we're going to do assert type, and we're going to pass in our variable that we created, so is game over. And we expect that this type should be a Boolean. Then we're going to assert, and we're going to do equal. So this method will allow us to pass in two values, and it's going to assert if they are actually equal to each other. So this is going to be is game over, and I expect this to be false. So then what I'm going to do real quick is I'm going to fix this. I'm going to revert this back to connect4. If we go ahead and save, if we try running our test again, we should see now there is a new test and then it does pass. Perfect. All right, so now we're going to add in our three other tests. So what we're going to do is I'm just going to copy this block of code. I'm going to paste it 2 more times. So we did if the game is over. So we're going to go ahead and check that there is no game winner. So we'll do should initialize the game with no winner. So I'm going to do change our variable to const winner, and we're going to reference the winner property on our connect4 instance. And then so for our type, it should be undefined when our game is first initialized. And then we'll want to check that the values are actually equal. So we'll copy winner, and we're going to pass in undefined. So next, we're going to check if it's the first player's turn. So we'll do should initialize the game and wait for the first player's input. And what we'll do is we'll reference player's turn. And then we'll call this current player's turn. And we expect player's turn to be a string. And we'll expect this to be equal to player.1. All right, and so for our last test, what we're going to want to do is check our board state. So what we'll do is I'm just going to copy this block of code here, paste it here. For our test name, we'll do should initialize the game, and I should initialize the game with an empty board. All right, so to actually validate that our board is empty, what we need to do is loop through all of our elements in our array, so all of our rows, and then loop through all of our rows and make sure those values are actually equal to 0. So to do this, we're going to make a new variable. We're going to do is board empty, and we're going to set this equal to our connect4 instance. We'll reference our board, and then we're going to call every. And so inside here, we're going to create a variable. We'll call it row. Then for our rows, what we're going to do is we're going to use row.every. And inside here, we're going to call this a cell. And we want to return our cell is equal to the value 0. So what we're doing here is we're referencing our board, so our array, and we're calling the every method on it. So every is a way for you to validate that every element of an array passes some type of condition or test that we specify. So for our condition, what we're saying is that each of our rows must only have values that are equal to 0. So we're returning another every here. So in this instance, we're saying every element of our row array must be equal to 0. If it's not equal to 0, this is going to return false, and if that returns false, overall isBoardEmpty will be false. If every value is equal to 0, then isBoardEmpty will be equal to true. So then, now that we have this new variable, we just need to assert the value of isBoardEmpty is what we're expecting. So we're going to do assert equal our isBoardEmpty, and we expect this to be equal to true. Let's go ahead and delete that code. Go ahead and save. Let's go ahead and try running our test suite and make sure our new tests actually pass. All right, so now our code runs and we see that we have an issue. Should initialize the game with an empty board. All right, so if we take a look at our test logic, so here's our issue. We're not actually returning this value here, we're returning an object here. So what we want to do is change this to return row every. Now if we rerun our test, we'll see that it passes. All right, so now that we have those tests out of the way, we're going to go ahead and add in the test for resetting our game state. So to do that, we're going to go ahead and just copy our function code here. I'm going to paste it down here, and we're just going to create a new setup function for our reset game test. So we're going to do setup reset game test. And then what we're going to do is we're going to go ahead and create a new suite. So we have our Connect 4 reset game suite. We'll update our suite name. We're going to do reset game. Then what we'll do is we'll go ahead and update all of our variables referencing this new suite. I'm going to go ahead and get rid of our instance test. And then instead of should initialize the game, we're going to do should reset the game state. So we'll do should reset the game state, and the game should not be over. So let's go ahead and copy that. So place that in each of our tests. So we have should reset the game state with an empty board. Fix that. Should reset the game state with no winner. Perfect. So then finally what we need to do is actually reference our function down here. Oh, and we need to change one more instance. All right, and so for our reset game test suite, there's one other thing we need to do, and that is update our logic that runs before each of our tests. So currently in our test suite, every time we run a test, we're just creating a new instance of a Connect 4 class. We're not actually invoking our reset game method. So what I'm going to do is I'm going to do Connect 4. The first thing we're going to do is we're going to call make move, and we're going to pass in 0. Then I'm going to do Connect 4, and we're going to call our reset game method. And so now what will happen is each time one of our tests run, the first thing we're going to do is create a new instance of our Connect 4 class. We're going to make a move, so attempt to place a game piece onto our game board. Currently, our logic isn't doing anything. However, once we add in that logic, this will have the functionality that we want to test. And then we go ahead and call our reset game method, which should reset our game state. So now if we go ahead and save, go ahead and run our test, we should see that everything is working as expected. Now that we've created our tests, we're going to go ahead and modify our original class a little bit to make sure that our function is actually working. So right now, we're not allowing the player to modify our game state at all. So we want to go ahead and just test that our logic is doing what we want it to do. So to do that, I'm going to change isGameOver. I'm going to set it to true by default. For our player's churn, we have it set to 2. And then for our game winner, we're going to go ahead and set this to player.1. So now in theory, if our functionality for initializing our game state was not working properly, one of our tests should pass because we're expecting our board to be an array of empty values for 0. We're expecting player's turn to be player 1. The game should not be over, so it should be false. And we expect game winner to be undefined. So if we rerun our test suite, we'll see that our tests are actually validating that our initialization logic is working correctly. That's exactly what we want. So now that we did that, I'm going to go ahead and reset these values back to the original values. Perfect. All right, so just a quick recap of what we did here is we created a brand new test suite for testing our reset game state and for our game initialization logic. We added additional tests. For each of our tests, what we did is we checked that our internal state is set to the values that we expect it to be. And what we did is we started using the UVU assertion framework, the library, to go ahead and test the types of our variables and to actually test that the values are what we expect them to be. All right, with that, that brings this video to an end. So thanks for watching. I hope you really enjoyed the content. In our next video, we're going to take a look at adding in the game logic for allowing a player to place a game piece into one of our columns.